All right, good morning, everybody. Today is day 3. The next 2 days are actually going to be the digging into the actual use of the software and a lot of the stuff that we've been talking about for the last 2 days. So we've got Seth and Corey this morning, and they're going to be talking about view matching. So I'll pass it over to you guys.
Thank you. So as Jeff said, my name is Seth. Again, I'm an art director here at Neoscape. And what we're going to be covering this morning is view matching. Our topics are going to focus primarily on view matching still imagery. We're going to sort of do 3 different presentations. One will be, or the first 2 are going to be more, I guess, the brute force method. One will be an image that we receive from a client and how we deal with the unknowns of an image and sort of gleaning data that we can from camera raw information or metadata, and then other techniques we use just to sort of figure that out. The second piece is actually a photo that I took with our in-house gear. It was a 17 millimeter tilt shift. So we'll look at view matching a hero with that tilt shift, and then also how we, with that tilt shift, I also matched what's essentially a stitched photo, which can also be a little bit difficult if you're not the one controlling that. And then the third piece today, Corey is going to go over some of the new view matching plugins and pieces in 2014. So it'll be a pretty good little gamut of the view matching piece. So with that said, let's start. The one that we're going to begin with today is an aerial that's not displaying properly in Bridge, but it looks like this. This is the raw JPEG that we received from the client. So one of the first things I do when I start a view match is you get the image in. If you didn't take it yourself, one of the first things I do is I pop into Bridge or a program that can display the metadata information of my image and start to look and see if I actually have anything. Luckily enough, this one does have some metadata where we can begin to use some of these pieces to understand how this was taken. We can see that it was taken with a Mark II. It was using a zoom lens, the 24-105, which we have the same lens here in the office, and I've shot with it before. So kind of know it's a good lens and what to expect. And then it was shot around a focal length of 35. Again, when I see something like this, I usually think that's sort of the best bet, but it could have been a little bit above or a little bit below, because it does kind of round those numbers off, depending on where the guy was. He could have been right at 35, maybe not. So at least we have something to start with. So what I'll do then is I will take the image into Photoshop, and we start to set up a few things that will help us in beginning this view match. One of them is crossing the image from corner to corner and then putting a little tick mark right in the center. What this will help you with is once you get this into max, you're going to want to make sure the target of your camera is located in the X and Y position in your max file, approximately where the target is shown here in your image. And I'll show that here in a little bit when we get into max. The second piece that I'll put in is a horizon line. Again, for this one, as you go back in the image, it does get very hazy and foggy. Actually, it's a little bit better up on that screen for you guys. On my screen, it's kind of hazy, so I just put a horizon up there, which is pretty much in the right place. So I can use that as a reference point. And then for this particular project, our site is actually this little block right here in the middle of or sort of off to the right of the middle of the image. So what we want to do is to draw some perspective lines. And generally when I draw perspective lines, I'll draw ones that are perpendicular to the other ones in different contrasting colors so that you'll be able to see them a little clearer in 3D Studio. One of the last things I do as a check is just try to figure out if, again, this photo came from somebody else, so it wasn't something that we shot. One of the things that I'll also do is I'll draw in some verticals in my image. And what this will tell me is whether or not the image has been vertically corrected. So if you have an aerial image, especially if you're shooting from a helicopter down, you would expect that the verticals would not be straight, right? The verticals would be straight in the center, which they pretty much are here. And then as you move from the center, they're going to start to slope up because you're looking down. So just with this, I can tell that the photographer who took this probably didn't do a lot of vertical straightening to the image, although he may have done some other things. And some of the other things that I look for in these kind of images is, you can, if you don't have metadata, let's say, from a camera, I'll start looking at perspective lines, either in an aerial or on the ground. If the perspective is really flat, meaning that there's not a lot of angle change of the lines, it's probably something that they used like a narrower, longer, like telephoto lens and really zoomed in. If there's a lot of exaggeration or a lot of movement in the perspective lines, like when you see a building that has a really sharp angle at the top, you know that it's probably more of a wider camera lens. So again, just thinking of those particular things can kind of help you troubleshoot this. From this perspective and sort of knowing the lens and the camera, this definitely seems to be something that's in the 28 to 35 millimeter range. So that's why I was pretty comfortable with the metadata that we were shown. And then a couple of side notes, and we'll get into this a little bit when you get into 3ds Max. Never try to match stitched photos. So if you get an image from a client or you're starting a view select, and actually the next thing I'll show this with the tilt shift, you want to start with one image always, and then match that image and then make the other images work with that image. And I'll show you some techniques on how we did that in the tilt shift. If you get an image that you think has been stitched, or you're having a really hard time matching it with the data that you have, it's always a good thing to check, because those can really cause problems if you try to do a stitched image. When you get into Max, you want to make sure you build as much context as you can. For this particular project, you'll see that we built essentially this pyramid shape here, this diamond shape here, which included 1 or 2 blocks on each side. Building more site and building sort of the longer lines, like the curbs in the site, is going to help you match your perspective better than if you just have your site in the middle of or like if you just had your project site, right? And there's a couple of methods to do this. One is, and I think we showed a little bit of that in the animatic. One is to use the animatic stage yesterday. One is to use Google Maps. The other one is to use OpenStreetMap, where you can actually download vector data and import that directly into 3D Studio Max and start extruding. So let's get into Max. So I'm going to go into a top view here, just to give you guys a little bit of a look on how we started. We had the project site from the client. So we knew what our project site looked like. And we actually went in then in Google Earth Pro, got a nice high-res map of the area, and started to map in the different blocks. And then we went a little bit further and we're able to get many of the different context buildings and their general proportions off of Google Warehouse. So with just a few little sort of online queries and searches, we were able to build primarily most of our site. So that gave us sort of a heads up in getting that done. So another thing I like to do when I'm doing view matches is once I start view matching, I actually make all my geometry in my scene very simple when I'm doing the initial 5 to 10 different cameras. I know some people tend to just adjust one camera over and over. I tend to adjust cameras based on moves and what I'm trying to accomplish. So if what I try to accomplish in that next step doesn't work, I can always go back to where I was and sort of rethink and start over. So what I did for this particular project was I made just a massing of the roads, because that's what I drew my perspective lines with, or I drew the perspective lines of the roads. So I just made a massing of the roads based on this context model. And then when I started doing my camera match, I turned everything off just to make my scene a little faster. Again, once when we start, you'll see that I did this to get the basic thing down and the basic move, and then once I got that, I started getting my refined cameras. So again, it's just the way that I work, and it just seems to speed things up. And I find, the one thing I find a lot of times for me with view matching is that if I have too much detail on the screen, I tend to get overly focused on the detail, and I'm sort of missing the bigger picture. So I try to make strategies that make me focus on detail when it's really close, and not when I'm trying to set up the camera from the initial stages. So we'll actually turn back the sight here for just a second, and we'll talk about the camera. So looking at the view, if our sight is here, I know that we're southeast of our sight looking northeast, right? And as we talked about, our target, when we look at the image here with the perspective matching, we know that the target of the camera is just north of this park, about a half a block or so, something like that. So what I did was, when I set down my initial camera, I came into, if you look at it in the modifier panel, came in with a V-Ray camera, targeted. It's a 35 millimeter camera, and I just drug it from the bottom left to the upper right. And then I know that that target is about a block or a block and a half, or it's north of this baseball stadium. So I just drug that target up to that position. And that's where I started. So what we'll do now is we're going to load our backplate image into our scene. So the shortcut for that is Alt-B, if you're not familiar. And you'll get your viewport background here. You just want to load in. I'm going to load in one here with the perspective. And you just need to match your rendering output, which the image was 3600 by 2400 initially. I reduced that in my view matching comp to 1500 by 1000, just because the lower resolution your image, the easier time Max is going to have displaying it in the background. So we have our, now we have our backplate image in, and if I go into shaded mode here, you can see our sight below. So now we can start our view match. So when I start this, I'm going to turn off my sight, and I'm going to leave just the green sort of massing for right now. So one of the things off the bat, I made my camera flat when I drew it in, right? Certainly if we're in aerial, we're in helicopter, and we're looking down, we know that that's going to be a little bit different, and that the target's actually going to be down at the ground level. One other guess that I made, I've flown several local aerial flights for this kind of photography, and generally you're around 1,000 feet. It's just kind of where the pilot feels most comfortable and the most sort of typical height that you'd be at to shoot around here. So I just made that sort of logical guess and typed in 1,000 for my camera to begin with. So now we're just going to drop our target down, and as you can see, our sight starts to come back up. We want to put, again, it's just a little bit of a guess, but I'm going to just drop my camera down here so that the horizon pushes up. Get it, and then maybe some range in here. So now our sight's aligned a little bit better, but it's definitely the horizon's a little bit too low. The sight itself needs to move down as well. So what I'm going to do is just take the rig and I'm going to move it locally, or sorry, I'm going to take the camera, move it locally to make our site just a little bit bigger. And maybe a little bit much on that one. So going to let's back out just a little bit. And let's start to move this down just a little bit more. And then we'll come back. And so a lot of times I tend to work in 2 different viewports. I know some people work in 3. They'll have a large screen at the bottom and 3 across the top. It's just a preference. I prefer to have my image as large as I can, and then just kind of massage it based on where I'm at. So let's just, I'm going to need to move out. Need to turn this a little bit more. And we're going to need to move laterally. So again, not necessarily a perfect science, but just sort of moving and working with your camera to get it to, so things start to line up a little bit more. And that's where those perspective lines really start to come into play. So we're getting a little bit better now. And so all I want to do is, I think this needs to shift down a little bit. There we go. And then undo that. And we'll just shift back here. So now we can see that just with moving the camera out, moving the camera around and having some of those things, we're getting the camera a lot closer to where we want it to be. I think we just need a little shift here. And then we just need to check our rotation a little bit. And get the camera shifted a little bit more over to the side so that these lines are more parallel. Now we just need to drag that into place. Let's just try to square this off a little bit. And I think we just need a little bit more down on our camera there. So now we have something that's fairly close. So what we can do is just do a quick test render of this. And what I've done in my, when I do camera matching, I tend to, I'll make a V-Ray override material or a self-illuminated override material, and I use the V-Ray tune shader to actually light or to give the so I need to turn on my tune to give my sight lines to give that sort of nice line on the edge of the geometry, right? Once we go into Photoshop, then we can take we can take that, drag it into our image, and then I usually set up a folder which is inverted and has a lot of contrast in the levels. And it will turn those lines white. And then we can see here, I'm a little bit off on some of these points. But overall, it seems like I'm a little high. The perspective on the road might be a little bit off. But you know, we're closer here. We're a little bit off here. We need to turn a little bit to the right. But it's pretty close. So I'll take my camera now. And I'm just going to make a new one. And then my layers, I'm going to just turn off my old camera. And let's just make sure my view is set to the new camera. And I'll pull up my transform again here. So I want to shift a little bit more on my X. And I want to get a little higher on this to bring down those edges that we saw. And then just going to turn a slight bit more. To get a little bit of that perspective fixed. So bring this back. I tend to use, when I'm doing these fine details, more of the transform type-in rather than using the dolly tools and stuff, just because I like a little bit more control. Again, that's always, I guess, the artist's preference and how you want to do that. And then I'm going to come up just a little bit more here so that the perspectives line up, and we just need to do a little bit more with the rotation of our camera. And I tend to use the rotation of the camera more than the target. Again, that's just my method, and we can see now that a little bit more turn up of the camera, we're starting to get everything lining up pretty nicely. So I'm liking these a little bit more. I think it's going to be closer. So what I'm going to do now is I'm actually going to turn off my massing. One thing I have in this scene too are our traffic lines, which, although they're small, they're going to give me the key intersections of the perspective lines that I drew earlier. So I'm going to turn those on, and I'm going to do a quick render of this camera. And again, it's just going to be those lines, but all I'm trying to establish is that my four corners are working correctly within my perspective. And we'll take this one, drop it in. And if we do zoom in, I'm going to turn off my verticals here, just so it's a little clearer. But we can see with the perspective lines that I've laid out, and it's a little difficult, but you can see the white there. You can see that the major intersections are lining up. The perspective is correct from the back and the foreground. So I'm feeling pretty comfortable at this being a close match. So what I'll actually do now to prove, so do the proof of concept of this, is I'm going to turn on all my site with the context buildings, but not my building yet. So let's turn on these buildings here. We'll just do a quick test render of that. I will say, and we'll get to this here in a second, the one thing I was not able to match in this view match was the horizon. No matter what I tried, I could never get the height correct, perfectly at least. It is definitely the same level and near the same height, but that's one thing that focusing more, the one thing I found for this particular project was that I need to focus more on the project itself than view matching the entire image, although I wanted to make it perfect, especially if it's coming from somebody who you don't know exactly how they did it. Like this image could have, the one suspect thing to me too is that the horizon was perfectly flat for an aerial image. If you shoot helicopter images, most of the time you're going to have some sort of tilt in the horizon. So the fact that it was perfectly flat makes me think that there was a little bit of post done on this in the sense of straightening some verticals and things like that. So that it was in the right, sorry, the question was it cropped? It was actually a different size, but the correct aspect ratio for a Mark II. So again, it could have been cropped, but it was definitely smaller than a normal Mark II image. So seeing some of those things, I kind of gave up on trying to make it perfect and did more to just make it work, which is, you know, if you look at this particular image now, this is my sight lines, those like long linear lines, plus the context buildings we brought in. Again, not perfect. We're a little overrun here down to the south, but the perspective lines match. Where they don't match is sort of where there could be topographical changes. Like, you know, it seems to match very well here. The perspective seems to match, but down here, it's similar to the perspective, but it's a little higher. So I look at that kind of thing and account that to topology. Like there's probably a slope on that road over a distance. But you know, all my verticals and the context buildings and all that, all those areas are lining up, and especially my site and my area is lining up. So what I'll do next then is just come in and we're going to, I'll switch my tune. I made a slightly larger tune for the site. So now what I'm going to do is just do a test render of my building. We're going to turn that on. and I'll just name this final. And one thing we want to turn off, let's just turn off our context building so all we get is our project site. So just to look at this before we render, we now have our building blocked in, and you can see that it seems to be fitting well, at least in 3ds Max with all the verticals in our scene. So let's just do a test render. And I will say, as I was preparing for this particular presentation, I spent about another hour trying to get the horizon to work, and I honestly couldn't get any closer. And the one thing you will learn with view matches is that definitely the most important thing is always the foreground, or what you're actually view matching. And as it goes back in distance is where you're going to get discrepancies, even if you build context models and things, just because whatever you build in Max, especially if you're using like a projection map, like a Google map, things like that, are not exactly accurate, right? And those accuracies will get sort of exponentially larger, or the inaccuracies will start to get larger as you go back in distance. So trying to use things really far away to line things up makes view matching a lot more difficult than using the things in the foreground. And then let's just open our final.
I've got a quick question for you. When you're doing an aerial such as this one, and you're given this photo, and let's just say, for example, the photo's about 4,000 pixels wide, I would have a client invariably say, well, I want to see more detail on the building, I want to be closer, but then you don't have a photo that's suitable.
Yeah.
It's very grainy. What do you do in that instance?
Okay, so there's two options. You could sell them on reshooting with a new perspective in a similar way, right? Because the one thing that is always necessary to make clients understand is that no matter how much you plan a shoot, they're always going to be different, and things are always going to change. I've done a couple of shoots around the airport, and we'll do planning for a week, and then you go there that day, and the winds change, and the planes need to come in a certain way, and you can't fly the way you thought, right? So definitely you want to have that conversation of, well, we can reshoot, and what are the advantages and disadvantages of that particular thing? One is the view is probably going to change a little bit, and it's good to give them a realistic expectation of what you'd actually be able to accomplish, right? If you have a Mark II and a 100 to 400, how much closer could you actually get to the building? If it's a 25% thing, then if it's really small, like 25%, I would present them with a different solution. If it's something where you get 400% closer, it might be something that they'd be interested in, and you could sell them on that and then do the next image. If it's a 25% thing, you can use Bridge, or you can use Photoshop and some of the tools in Camera Raw to start to essentially use Photoshop to enlarge your image, and then use Camera Raw to start sharpening and doing some tweaks to get rid of the blurriness that's going to come from that. And you could probably do just a 25% thing with Photoshop and Camera Raw, and then match it again in Max, and work with that. But you'd still want to do your view match on your original plate and just render larger, right? Does that answer your question?
That does. Thank you. Hi.
Now, in order to resize the image, sometimes when you're resizing the images on Photoshop, you tend to get a lot of grain still. So we usually use Alien Skin Blow Up as a plugin. I don't know if you have other plugins that you use in order to resize images and still have a finer detail on the grain.
Yeah, so we don't. I've heard of that particular program or plugin. We don't use that in house. We would, depending on the situation, probably do one of those two scenarios of what the purpose of that actual image is, and how we could do one of those two things. And then if neither of those worked, then we'd probably explore something like that and see how well that could actually solve that particular problem.
Okay. Now, in the event of, let's say that reshooting is out of the question because you'll involve all the costs associated with the aerial shooting and so on, and you're stick to this photo, but from the marketing perspective is not the best angle for the building, and you want to have like different connections, and at the end you decide that is a slight change of the position from that camera angle. Usually when we confront those situations, we end up modeling part of the context and using part of this photo as foreground and background. At some points, we could take the context buildings and straighten up the facades and paste those maps to our boxes to the boxes of the surrounding context. But I don't know if you have another methodology or if there's any other software that probably with this information can already automatically map the scene and make you just simply move the camera. That will be ideal, but
yeah, I mean, so the strategy that you talked about sort of making it a combination of a matte painting exercise, a 3D exercise, and a modeling exercise is definitely one way to go. That would probably give you more flexibility in some senses. There's definitely the thing if you had some general massings of, like, say, this project is here in Boston. The BRA, which is the Boston Redevelopment Authority, provides a massing, like they have a massing model in CAD of like the entire city, right? So one way that might work is to do some sort of camera match, right? That you're projecting this particular image on this bed of geometry, and then but ultimately, like, you'd have to almost do a test of that to see if you're comfortable telling the client that we can move, but even with that, you can move 5 degrees, right? Like you're not going to be able to take an aerial like this and get a shot where you're looking directly at the facade of the building, right? So it's really going to become a thing of talking to the client and working with them and figuring out the angle that works. And going back to our shoots, if we were to shoot something like this, we would, generally what we do is we do high far, mid, or like a little bit lower far, and then we do a couple more iterations at a higher height and a lower height closer. So even if we previs something and they seem to like it, when we go up in the helicopter, we'd rather pay for the extra 40 minutes to do 3 more loops than the one they selected, just to have all that stuff. So we'll do a shoot. We essentially say to the helicopter pilot, like, that's the site, fly around on a pin, right? And you just shoot as fast as the camera will let you. So you'll have 360 degrees of images to be able to have them select. So again, that's an advantage of selling them on that particular product that you can give them, because if they want to change, you might have another option that wouldn't be necessarily locked into.
For a project like this, usually how many hours of shooting time, aerial shooting time, do you budget for?
For a shoot like this, if it's just one building, the place we use to fly out of is Hanscom Air Force Base. It's about 30 minutes outside of Boston. We can get into the city and back out to Hanscom in less than an hour and do between 3 to 4 rounds. Again, it depends a little bit on where you're flying and what kind of things you need to. We generally, when we're flying near the airport, we typically allot a little bit more time because we generally have to deal with some other scheduling thing, right? With planes coming in or more activity. Like shooting in a downtown, I would allot for more activity than something where you're shooting in like a suburban area with less air traffic. Yep. Any other questions? I think there's one in the back, Jeff.
Hi, I'm just wondering. There's a lot of guessing when you do this stuff, and I've been doing this a lot too. But lately, we've been the city has been demanding us to use GPS coordinates for all our shoots, because we have some pretty unlucky cases in Denmark where buildings have been taller than they should be.
Yeah.
So now we don't have all these big buildings in Denmark. Do the city ever demand in Boston or in the US that you deliver a 3D model with GPS coordinates and use the metadata from the photos? Or is it just guessing every time?
So, when we fly shoots, we know, like, we'll pre-visit and we'll say we're going to fly about this far out, about this height. Right, so we kind of know, because we'll build this model. We'll put in a camera with the correct optical. We're just going to say we're going to shoot 24 millimeters, right? And so we'll use that camera. We'll know kind of where we're at when we do it. But no, we've never had that specific request of like. I've never dealt with that specific request, at least. I can talk about that a little bit.
So. Here in the U.S., we don't have quite the same requirements that they do in Europe. They talk about verified views. It's really big in the UK, I know. And there's a couple of places, they have developed sort of methodology to be able to sort of prove to a certain degree that the view is accurate. We don't have those kinds of requirements here in the U.S., and we haven't had, only once or twice have we been involved in a court case or something where they wanted to have a lot of backup. And, we have done surveys as we've done view matches and things like that. But it's not a requirement here, and so it's not something that we deal with on a super common basis. I do think that the UK leads the sort of industry when it comes to the idea of verified views and proving that something is as close as it needs to be. We do try to back up with as much information as we can and provide as much context to know that our view matches are correct. We don't ever fake a view to make it more attractive for a client or for a circumstance, but you also still want to make it within, if you were going to use, these kinds of tools to tell a story, you want to make it look as good as possible, so you want to shoot it a nice time of day with the good lighting and as pretty of sky, as you can get. But no, we don't typically have clients who do require backup to the level that they are in Europe. Back when we had done it, the idea of a GPS sort of data being available didn't really exist, and so we have done it more from when we've done it. It's always been from the ground, and it has often been we would use known surveyed things like manhole covers and telephone poles and things that were in the engineering information, and we would put requisite geometry in, and then if we turn it on, we say, listen, if the engineering information is as good as we can get, and the photograph is from where we know we took it, and the lens is exactly what we think, within a reasonable doubt, as an artist, we can say this is as close as is possible. But because the idea that someone could reproduce, from a scientific standpoint, if you could reproduce and get the same results with the same input information, that's usually sort of good enough for most circumstances, at least, again, here in the US, where there hasn't been quite as much of that legal challenges to images as there has. I know that in New York City, whenever we do images, they require that the brochures go in front of the Attorney General or someone from the office of the Attorney General, and there they require that they put, artist's rendition somewhere in the images. They basically require that people say, listen, you need to know that this is someone's interpretation of what something is going to be, and it is not, you can't, there's a level of expectation that things will be, within a realm of similarity, but it's not necessarily an absolute guaranteed representation of what's going to exist. I hope that helps. I know that, like I said, in Europe, I would talk to the European guys. There's a lot of really, certainly studios like now I'm drawing a blank. Where Alex Morris was, Hayes Davidson. Hayes Davidson does a lot of verified views. Alex Morris, I think, worked on the process. Yeah, Assembly, Uniform. Tons of the UK studios do verified views. Smooth, or Assembly Studios, Assembly now. So yeah, that would be the place. And it does seem to be regional. Seems to be different places have different sort of expectations. I don't know what South America is like. I don't know what, we do a lot of Middle Eastern work. We don't typically seem to get much pushback from, showing whatever we want. So we have been lucky in that regard. Anybody, anything else? You guys are good? Anybody? We're good?
Jeff, is there any online questions? Okay. So I think just to go back to look at that final image that I brought in, again, I have just a simple mask here in Photoshop of our building, and you can see that if we did a quick check with our rulers, we have verticals that are very similar to the surrounding context. Our perspective in the face of the building is matching the road. One thing that is a little bit deceiving in our match when we did it initially is that these two curbs actually aren't in the same plane. So this one is actually farther back. So when we were initially doing that, I kept thinking we were wrong because this was farther back than the other one until we looked at it in a top-down. So it's always good to make sure you look at those particular things and check that. So this is a pretty good view match then for us to start working on doing the rendering. So we're going to close that, and then we're going to go to the next example, which is a hero image. At the end, we're going to have something that looks like this. So this is, again, the same project, but shot down from the street level. And because of the really tight constraint in the street, we ended up having to use a really wide lens. So we have a number of different lenses, but this was our Canon. We have a Mark II, and it was a 17 millimeter tilt shift, pretty much as wide as we can go here. So the site is right out here in front where you see the two cranes. Again, starting off with this particular image, the two images I want to actually match were actually these two. So it was, again, a little bit of an experiment for me using the lens and the tilt and making sure that we matched it correctly in V-Ray. So there's two different images that we stitched together, but again, you don't want to stitch it. You don't want to match a stitched image. You want to match the original here. So the original image was the standard Mark II size, which is 56/16 right wide, and then I size it down to 1500, again, just for ease of use in Max. I put in the vertical lines of the different buildings. This one here was a bit of a guess because the building goes back in distance, but we can't actually tell where it is. So I drew that really tall to tell myself that it was more of a guess of where that back of the building is, not necessarily a hard rule. But I was able to get the front corners of the building here because this building here will actually be taken out in the new construction. So we won't be using that as a context building to match. And then the building here in the background. In my foreground, I drew just a simple line for the curb, for the orientation, and then use these, you zoom in on these buildings. The buildings have a stair-step pattern, and I drew in those verticals to help me when I set up my camera in the view match. So we save this out as an image, and I've already set it up here in the background. And what I know is this massing here is actually the building here on the right-hand side. Okay. A question?
Sorry, yes, on going back to that horizontal line, is that you mark that as a reference or as in the horizontal or as the horizon reference? The blue, the cyan horizontal line?
This is just a ruler line.
Oh, okay.
Yeah.
Okay.
Sorry.
Yeah.
I did put a horizon in based on, I used some perspective lines in the scene to give me a horizon. One of the things I know though is, because I shot this with the tilt shift, is it'll be flat.
Yeah.
And I know that in the view process, I always set it up as 6 foot because that's about my eye level, right? Then I remembered, and I'll show you this in the view selection or in the view match process, that actually the nice little thing here in the foreground is that the restaurant I was shooting in front of flooded the night before. So there was this crew of guys out there in the morning cleaning up all this stuff. So I ended up having to crank my tripod even higher and like stand on a little block to be able to get over some of the stuff they were doing in the foreground. So then I knew I needed to shift it a little to like 6.4 or something like that. But
we also have the 17 millimeter tilt shift, and for buildings that are about 30, 40 stories high, we tend to go to the, like, if possible, to the building in front and shoot from 6th to 10th floor so that we can be above ground a little bit. And sometimes what happens is that the street level will be on the lower side of the shift. So we will take the 3 shots, mid shift, lower and upper part of the shift.
Yep.
So we end up doing the camera matching on the lower portion. At the beginning, we used the same V-Ray camera lens, 17 millimeter with the lower shift, but I don't know if it's on our computers, but every time we render that, it seems that the proportions of the render are completely off from the lower shift. So I don't know if you have that same experience or if you have.
Yeah, and so you're saying you have a really tall image, so you take 3 photos, yeah, and you view match the bottom one.
That's right.
And then when you render it, there's distortion in the bottom as far as the perspective, or it shifts in the max viewport?
Well, in max, you don't take 3 renders and then stitch them. You have the 17 millimeter, and then you use the vertical shift. And the proportions of the image are usually vertical as well, but you're matching, your camera matching the lower portion. And on our computers, the render is completely off from what we see on viewport to what the final output. So I don't know if it's.
You're rotating your camera 90 degrees. Is that what you're saying? You're turning your camera 90 degrees.
No.
Or, staying in the horizontal format.
Yeah.
So
yeah,
when
the shift is.
When you do your camera match, off the initial image that you use to match, so you have your bottom one. When you add the top, do you also add in your Photoshop file image to the bottom? Like that space, if you're adding, so you have something 1,000 pixels tall. That's your initial image. You add another 1,000 pixels to the top. Do you add 1,000 pixels to the bottom as well?
Yeah, I think we're working with the full stitched image. No.
So
Yeah, but that could be one of the problems.
So one of the things I'll show here in the process is when we actually get to the final image, the selection on the screen right now is actually my initial image. So whenever you do a tilt shift or you do a stitched image that you're putting together, you need in your max viewport when you're doing the view match to be adding, if you add to the top, you have to add the corresponding amount to the bottom. And that's going to keep your Photoshop file in your max view match correct. So if you do the bottom and you add one piece to the top and one piece to the top, and say each one of those units is 1,000. So you have the original image, which is 1,000. You add another 1,000, another 1,000. You need to add 2 to the bottom. So you're going to have a 5,000 pixel image height-wise, but then you're going to get the right view match. Once you get the view match, you can make a selection of that and crop your image in Photoshop. And then once you render it, you can just use a selection to pull it in, or you can keep the whole sized format, right? Like any, and just to explain that concept, if you have any image, I guess if you make a selection in Photoshop and you have another selection in Photoshop and they're the same size, you should be able to drag it into the right spot, right? So you could use that technique as well if you wanted, if the size became too much and you wanted to render it in a way to make that smaller. Does that make sense? So you'd need to preserve that aspect ratio in max, but in your Photoshop file you could delete out those empty pixels at the bottom and use a selection to actually bring in your render.
I think that makes sense, but
Okay.
we don't have the, like, that happened to us a couple of months ago, and we ended up, like our viewport did not match the proportions, the rendered proportion was not the same as the final image, so we ended up like tweaking it here and there in Photoshop. But yeah, I think it makes sense.
Okay.
Thank you.
Is there another question? And so for this one, I'll work through this one just a little bit quicker because we have some pre-established cameras, but I'll walk you through the process here on how I did this one. And so again, we're using the same site model that we looked at in the previous image, right? The basic area, the context buildings, and we all know they're pretty much in the right place. So I know when I shot this photo that I was just to the left side of this massing, which is in the model, and sort of in front of this building here. So that's where I started with my camera. Again, like the aerial, I put in a camera, I pointed it towards the site, and this building is that building on the right. So I know that I'm generally in the area I should be. Then the first thing that I wanted to do when I set up this camera then was I wanted to get a little bit better of a horizontal position. So, sorry. I wanted to set my tilt first. So what I did was between those two cameras, again, V-Ray camera, as you were discussing, with the tilt shift, you can pretty much plug in the numbers, and I knew I took it, so I knew 17 is a good place to start. And then what I use for the tilt shift is this vertical offset. So my initial vertical offset, if you just go back here to 0, this is how it came into max with the camera and the target level. If I do that negative vertical offset, you see that now it's taking that tilt shift into accountability, and the whole site starts to drop down. But looking at these buildings, this building needs to line up with the orange. This building needs to line up with the red. So I need to do some horizontal positioning and replacement. So I'm going to, my next camera took that into account. So I just rotated the camera and also, translate it in the X and Y to start shifting it into the right position. And now you can see that this line here is starting to line up with our orange. And again, as I was saying, that this orange line is my guess based on kind of how big this building is and where it actually falls in the photo, because I can't tell because the tree's in the way, which is a little bit unfortunate. And you can see here that these massings, the verticals are lining up in the correct proportion with the reds. They're not exactly on, but they're pretty close. And then I wanted to, this is the point where I selected the camera and I realized that I was standing on my tiptoes and I should probably adjust the camera just a little bit. So the other camera was at 6 foot. If we look at this one, give me a second here. The other camera was at 6 foot. The new one, with a slight vertical, should be at 6.4. So I brought up the camera just a little bit to account. And again, it was a very slight shift, but something more that I did because I remembered I was taller than I normally would be. The fourth camera was just trying to adjust a little bit more the horizontal positioning of the camera, getting a little bit better of a twist than what we had before. So you can see the change here and just a shift of a little bit. And then the last one here is when I started, I got this particular alignment, and when I did the test render, and again, we'll turn on I started to get a lot of the lines together, a lot of the horizontals together, and then more of these background pieces together in that camera. So just get into our all right. So I just did a quick test render of this particular image. We'll open that. So we can see in our Photoshop file that our render here, actually let's just make a new folder. Is starting to line up pretty well with all those areas. And even down here. So across the back and at the bottom. So with that, and again, you can we could even go in and tweak it just a little bit more to get those lines perfect if we wanted, by just doing a little bit more work. By just doing a little bit more work. Too many cameras on. Let's turn these off. And just a little bit more.
There's a question online here.
Yep.
So let me read it to you. It says, as I understand, you should match one image, not stitched image. If you use stitch, we add same sizes on top and bottom or in left and right. Is this correct? And what option should I use in Photoshop for stitching? We have a few options in Photo Merge.
Yeah, so I would, when we did this stitch, which stitching tilt shift images is a little bit different because there actually is no distortion. So if you have a normal camera, and let's open this file. So the two images we used for this were a base image here, and I'm going to turn off their masks real quick, and then an image here. I would use this base image. With tilt shift, there's no distortion, so you can just literally add top and bottom. If you're doing an image where you're not using a tilt shift, you're using like a zoom lens or like a fixed lens, you're going to need to rotate your camera up or down depending on how you're shooting. And at that point, what I would do is I would view match your bottom image, take your top image, put it up top, and then I would actually not use Photoshop. I would use the transform tools to stretch that, stretch the top or the bottom, I guess, depending on how where you're adding the photo, to stretch that in a way that's going to stretch the image correctly to match the perspective. So that's one thing that, because if you use Photo Merge, it's going to start, Photoshop is essentially going to take over and start tweaking both photos the way it wants to, and not necessarily preserve one that'll be good for view matching. So I would recommend doing that sort of distortion or transforming on your own so you know that it's done right. And if you end up having to stitch like 4 photos together to do something in Max, then in the sense of like you don't have a central thing and you're trying to stitch a bunch of corners or something together, like it's going to be really difficult for you to get something right. To go back then, so now I've just fixed those verticals. So if we do sort of final test on that. We should see that the verticals on the side, which were kind of the problematic pieces of that last image, although they were close, they weren't quite right, should be a little bit better. So now we'll bring that in. Sorry, this is the one we want to bring that into. So now we can see that those verticals are aligned better, and that perspective is still matching at the bottom. So we're pretty good now. Now we just need to add our vertical shift. So let's come back into this image here is automatically, or is already set up for the correct proportions for our tilt shift. So if we have this image here, we do a quick the pixel, or the image right now is 1,000 pixels tall, the one we matched. If we go back and we just uncrop that, the two images together, if we select both of those and we do a crop, is 1,380 pixels tall. So we know that the original image was 1,000 and the additional top is 300 more. So what we want to do is we want to times 380 times 2, so 760. And we want to make sure the image that we set up for our next view match to take into account the adding of the additional image on the top includes both of those. So this Photoshop file is set up at 1,500 wide, 1,760 tall. So the stuff we're adding at the top is also reflected in the bottom. So I've saved that out here. So you can see, again, we're still keeping our markers and such, right? But that extra space at the bottom is just reflected as being red here, and then the additional space on the top. So now we want to load this into Max. And we want to make sure that our viewport reflects that aspect ratio change as well. So we want to change this to 1760. It's going to get a little bit taller. We want to change and add that base image with the additional sky, 1,500 by 1760. And now we'll see that a lot of our lines still work, right? We're getting essentially the same match that we had before, just top and bottom. So, and let's actually now turn on our building. So one thing that we notice, if we just match the tilt exactly on how I photographed it, our building, it's not actually tall enough. And again, I didn't really know this because we didn't know exactly how tall the building would be in that context, so we just shot, the initial image had a little bit of tilt, and then I just maxed out the tilt all the way to the top on the lens to get the second image. So I couldn't go any higher. But if we then render this really quickly, we come back. We'll drag this in. So the image below here, this was the one that we did at 1,500 by 1,000. It was in the last image, which we did for the view match. The image on top here is the new sort of higher one. And you can see if we toggle those on and off, there's actually no change in the perspective between the two images. So the curb from the previous render and the curb from this one line up perfectly because we are adding the top and the bottom. And then the last step for this is just that I need to figure out a number that gave me more, a comfortable number that gave me enough sky above the building that I knew I could paint in a sky for the client, and still have like enough breathing room because the plates that we did didn't exactly work. So I did a little bit of experimentation with the full size comp, not the reduced size comp, to aspect or sort of a ratio in that one that worked for this. And what I came up with when I scaled down was that it should be 1500 wide and 2135 high. So again, you could do that even in this one. You just want to make sure you go to your canvas size, and I was just experimenting with pixels to sort of figure out which one would give me the right aspect ratio. And then I wanted to render this square, so I did a fixed ratio in Photoshop, and I knew I wanted to get some road and I knew I wanted to get some sky, so I used that and inverted it, and I knew that would be a crop that I'd be comfortable with producing the product at. So that's how I just determined the 15 to 2135. And we could render it again, but essentially it's going to work the same way that it worked for this iteration, that this would be in the same place, which is this
Thanks.
final image.
One of the problems that we always encounter with this type of camera locations using the 17mm tilt shift is that the renderings ended up with very little information at the pedestrian level, and there are some buildings where the landscape right in front is critical to have in this main perspective. Ideally, you shoot from the building in front from the second story, third story. But if that's not possible, are there any tricks on the shooting? Because it's only a matter of hiring your going above for only 8 feet. Are there any tricks that you use? Do you rent a van and with a platform, or is there any kind of special telescopic tripod that can be used? Or
so if I'm understanding your question right, you're asking if there's any method to get up higher so you don't get as much ground when you're using a tilt shift lens.
More context in the ground, and it's hard to see if you're looking straight at the context.
Yeah.
You can't tell if the match is good. So the higher you get, then you can see down on the.
Exactly. It's not really for having a perfect match. Like you can have the perfect match on this one, but let's say that this was the building that we were rendering, and there's more streetscape information, or the building has an important urban context right in front of the building that needs to be rendered, all that pedestrian area. So we need to hire our point of view for only like 8 feet. But it will be ideal if we could have that same information from the photo, and we cannot go to the building in front to shoot. Are there any tricks to go to location and place a special tripod that extend you for one story, or?
I mean, I've never had that particular situation, but I'm sure that I would look at like a camera rental store and could you use some sort of could you use a lift in projects we've had before? Yeah, like the jug lifts, like the 4 wheels with the hydraulic platform. It might not be necessarily great for 8 feet, but could you get like a piece of scaffolding structure that's like
I've stood
2
on
edges?
I've stood in the back of a pickup truck, or stood on the top of a. In our New York office, we have used the cherry pickers, a lift to get up, and the one problem is you're stuck on the street. You can't back up onto someone's, parking lot or driveway. Then also, we've literally stood on top of things, stood on top of vans, stood on top of bed of a truck, use as tall a tripod as you can find, sort of make do.
Yeah.
You can do it from a
Bring a
ladder.
ladder, yeah.
You can, just as long as you try to be safe. We do have when we have done the cherry pickers, we've had to get extra insurance, paperwork and stuff, because very often people will not allow us to be on their property if we don't prove that we're insured. There are considerations, but getting up high is definitely an advantage for showing the right type of project.
Does that answer your question? Okay.
Thank you.
Any other questions? Yeah.
I just wanted to offer another trick that I've used sometimes when I go to photograph a site. I bought a piece of 10-foot PVC pipe, taped off every foot and spray painted black, so black, white, black, white. It just gives you a quick reference on how to get some more accurate measurements, so you have someone go stand in the scene, because a lot of times I might be doing scenes that do not have a lot of vertical reference. So I'll just have someone stand at key points and plan with that pole, and it gives me some reference on, heights.
Hey Dave, you know what would be a good mod? One thing that might be a good mod to that would be to router out a little section and mount a bubble level, vertical bubble level, so then you could make sure that they're holding it straight too.
Over. Do you want to do a little introduction?
We've got a question online here. It says, what's your suggestion on reflecting the environment on glass for matching the building?
Yeah. So there's a couple of different techniques you can use. If you're, and I think we talked about this a little bit yesterday as well. Like if you're doing an aerial image, it's really easy when your camera's pointing down to use like a map on the ground to get proper reflections in glass and those kind of things. For ground level shots, what we'll typically do is take a photo backplate and use that, and maybe mix, alpha out the buildings so that only the buildings are being reflected, and then the image that we're using for the reflection of the sky comes in the glass for the reflection plate. Or the sky that's in the image comes in and gives the reflection for the glass. So, or you could also build those buildings. I think in this particular case, the project that I was showing, since we had those massings, when I actually went out to take the photos, I walked across the street with the tilt shift, and I just sat and took, essentially took tilt shift photos of the elevations of all the buildings, and then we just mapped them on, and those were then reflected in the building across the street. Oh.
I don't know.
I don't think so.
All right. So, my name's Corey, and I'm just going to try and speed things up a little bit. I know we're getting behind, so I'm going to rush through some stuff, and if there's questions, we'll address those more than the specifics here. But I just want to kind of end cap what Seth was just talking about with the standard camera matching, and then show you guys some tools in 2014 that have helped out in perspective match and things like that. First of all, this happens a lot in 2014, where the backplate is not actually like that. Different fixes for that. You can adjust the timeline on the bottom. You can open and close save frames, but happens a lot. And switching between cameras, you'll see it switch around a lot too. So just be on the lookout for that up front. Basically, what I wanted to start with here is another type of camera. I used a Nikon D90 for a shoot yesterday. The shoot was specifically for this, and specifically to show you a crop censored lens and how to match that. So a Nikon D90 is a 1.5 crop, which means when it shoots an 18 millimeter lens, it's actually shooting a 27 millimeter. And it does that because it's in a DX format, which instead of the 35 millimeter lens film setup or sensor setup, where it would be 36 millimeters by 24, that sensor size is 23.6 by 15.8. It also has a different photo size, so we have to be mindful of that. When I took this shoot, I went to a place where I know well, and I knew a lot about it. So to show you the scene very quickly, where's my layers? What I did was I took a Google map, put it on a plane, and I know exactly where the building is, and I know because I was the guy taking the photo exactly where I stood, so I can attest to that being my location for my camera. So it gives me a lot of setup information as far as position and distance and things like that. But what becomes a challenge with this particular camera and this particular 3D environment is that, for one, I rotated the camera 90 degrees on the tripod, so it's not using the horizontal aspect ratio that V-Ray cameras are standard setup for. And like I said, it's a crop sensor, so you have to be mindful of that as well. The rotating the camera on the tripod 90 degrees means you have to convert the field of view. And I'll say that I think you will always have a lot easier of a time using field of view rather than specifically the millimeter lens. Instead of using like millimeters, use the field of view. Where are we selecting? There we go. So what I did was, instead of using 18 in the focal length, I just checked on field of view, and I'm overriding that with a number here. So let's see. To be a little bit more clear, what I'm talking about is, so the field of view on a camera or on a lens, when you go to Google, this is the lens that I was using here. Google tells me that, or the stats on that lens tells me that it's a field of view of 76 on the low end, so the 18 millimeter, and 15 degrees, 20 arc minutes on 105 millimeter. And those are diagonal field of views. So if we were to use a standard camera, let me just pop one in real fast, we would just be able to use this right here and switch between horizontal, vertical, and diagonal. But because we're using a V-Ray camera, we have to do a touch of math to figure that out on our own. And that is what this quick deal is here. I don't have a scientific calculator at my desk, and I expect you guys don't either. But you can always just use Google. And what we need to do is just take this small deal to find our vertical field of view to use on our V-Ray cam. And what we do is to go to arctangent of x. X is our vertical on the image sensor in millimeters. So I go 15.8 and divide that by 2 times the field of view, 2 times the focal length of the lens we had used. So I'm going to say 2 times 18 millimeter. Using the same deal as what Seth had talked about, if you check the metadata, I'm just trying to speed things up. It does say I used the low end of this lens. It was an 18 millimeter. But the last thing with this is just type in degrees, so you're not wondering why it says 1.4. But what you get is this 47,392. And so, as I said, when you're in the V-Ray camera, tick on field of view and override it with a 47,392. You could have also just multiplied by 1.5, but I haven't really done a broad range of focal lengths on this to feel confident about just that simple math of 1.5 on the focal length. I feel it was more coincidental in this case. So doing the field of view is going to get you a lot more specific number. And then as you can see with the match here, it was near perfect with the geometry that I had in the scene. But just, again, using all the tricks that Seth just covered, I popped in the camera where I knew I was standing. I have the building where I know it belongs, and I know that because of a Google aerial that I have in the scene as well, and everything is to scale. So it took very little of moving that around once I had the field of view set up in that scene. And then, whoops, there we go. You know what I'm saying?
Would it maybe be good, Corey, just to show quickly, because you're saying you overrode the field of view
Yeah.
because you were shooting with an 18, but it's actually a 24. So what does this look like if you actually just do 18?
Yeah, so actually I did skip a step in trying to hurry through this. Sorry about that. The other piece of the puzzle here is that, like I said, it's a 1.5 crop. And so you have to invoke the zoom factor for the viewer camera at 1.5, because if we left it at 1, you're going to show it to me. This thing. I don't know why it's not going away. Anyways. So the viewport is having a go at me here and not adjusting. Basically, the building should be a lot smaller, but it's not adjusting. But to answer what Seth was just talking about, if we had just used the 18mm lens, it would obviously look very different, and things would be in a very different state. And you could still match that in sort of a very brute forcey type of way, but what you'd find is that camera would move completely off of its position of where I stood. And so you get a much better accuracy from the, I think it was 47.392. And then why that's not working, I don't know. So that was just a quick example to end cap what Seth had done with the other cameras. But for the newer stuff in 2014 here, I set up a couple of other scenes. Let's see, where is it? Let's go to the blank scene. No, let's just do the Neoscape one. Ooh, state sets. Okay. So 2014 has a couple of tools for matching images like this, images where you may or may not know the field of view of your camera. They have this new tool over here in the Utilities tab called Perspective Match, which is a helper tool for finding that field of view and ultimately setting up a scene where you can composite objects into it. So first things first, load your image into the background, get that thing viewed through Alt-B, and then match your aspect ratio for the safe frame. And then head over to the Utilities tab, Perspective Match, and show vanishing lines. These are all already set up the way I had for this scene already, but when you first open it, they're usually kind of grouped off to the sides, like so. And you can watch the home grid kind of bounce around, you'll see what's happening, but you just start to match them to a stable vertical in your scene. I'm going to use this out here. And then a stable y-axis. And a stable x. This will work. And you can kind of see that the home grid it's finding its way back to where it was. Because I had already done this, it was that simple. But a lot of times when you get the perspective match, you end up and you see the home grid kind of here, or maybe it's way over here. But you can trust that the perspective is working. You just need to move this grid into place. And so that's what these camera adjustment tools are for. they're all relative, so as soon as you let go of the spinner, they're going to just pop back to 0. You're not doing anything in detail here, you're just kind of moving it visually into place vertically, and then distance will bring it close to your camera or further away. And you know, so I'm going to just line it up with the front door. That a little smaller, a little lower, and a little more over. Yeah. And so now we know where our 0, 0 is, and we can composite other objects into the scene. I just popped a lighthouse in there because it was a model I could find. This ground plane is specifically to capture a shadow and potentially a reflection. Our concrete floors here at Neoscape aren't very reflective, but this one's going to grab the reflection just so that that can be seen. And then when we render it, you can see what happens here. Yeah. So now once rendered, it's a very quick way to comp in an object such as this, where you had, like I said, the reflection, the shadow cast. We know the perspective matches. The one thing that I should make clear is it's not a perfect camera match. And by that I mean it's not necessarily equidistant from where I stood taking the picture to that background object. What is exact is the perspective of everything. I can move this object closer to me, further away, without affecting the camera at all. Or sorry, not without affecting the camera, but without worrying about where that camera is locationally, because the background is stable and the camera is just moving relative to the object. But we can go ahead and use the same tool to try and help us out in the camera match, sort of duty of creating a render. And this next scene should hopefully show that. Let me change actually the background. There we go. Oh, there's only like 6 materials. So I'm going to switch the backplate that's there now. As soon as things catch up. Okay, so make sure that stuff's on the screen. Tends to look a lot better. Quickly put it into. That guy out of the way. Okay. So here I did the same thing using the Google Earth. Get rid of that. I had this image here in the background. Let me put that in wireframe so you can see it. We have this image where we took a fairly tall image of 177 Huntington over at the Christian Science Center here in Boston. You can tell by the bottom of the image that we stood across the street from it. And you can tell by the Google Earth that we are going to quickly encounter a mall building there if we go too far back. So we have this sort of narrow area where we know the camera belongs. And just so I can kind of show you some of this, I'm going to just pop in a free camera generally in that area and rotate that generally in the direction of the building over here. And whoops, let's do it in this one. So first things first, we're going to turn on the horizon line of our camera. And we're just going to use our transform tools to rotate that down into place. From working with this image in the past, I know it's roughly at the bottom of this this sort of horizontal bar above the door. So I'm gonna place that roughly there. Some of the people in the image help, but really with the topography, it's really hard to tell. But rule of thumb, if you don't know and you see a person in the image right around their eyes is where the horizon line should be. It should be about the same as yours. But once we have that set up, we can go over and turn on the perspective match and do the same show vanishing lines. Here is where I've run into a little bit of trouble trying to get a very exact positional match from this tool. With all three axes, it becomes a fragile system. It works, but it's actually very easily broken. And what I've seen happen is the camera starts to get scaled non-uniformly. It's not a bug that I can completely recreate, but it is something that has happened a few times over. And so as I drop in this third axis, I think it's going to start to freak out on me. But no, it seems pretty good right now. Great. If you do encounter an issue where you're seeing the building start to rotate to the side and you're not rolling the camera, things like that, basically when you move one of these axes, that should be the only thing moving. The tell for me when the system's kind of breaking apart was when I would move this and all of the other lines would adjust. And that was sort of a signal to me to just turn off one of the axes and get to a more viable setup where, you know, I really only need the X and Y of this one because it's so dead on. And so I was doing that to help clear up that issue. Did we just have that thing happen? No, okay, cool. And then, yeah, like I said before, you can use these same tools here to place the building where it belongs. Get that down lower. But you're going to have to do a lot of back and forth between this set of tools and the transform tools. If you have your camera selected, where you're actually going to do a little bit of rotating, maybe manually move it over. The last tool really in 2014 that can help out quite a bit in doing camera matches is something called 2D pan zoom. It's under the plus sign in the top left, or if you prefer the camera tools down here, the hand will expand to the hand with a marquee. And what that does is from your camera, you can zoom in and out on the back plate without moving your camera itself. So I just zoomed in and out too much. Here's my building. Redo it. So I have a little more control. And now we can watch more very stable corners, or we can turn those vanishing lines back on and get a lot more specific about where we place those handles. I can come down here. These guys around. Actually, I'm going to use the line down here is a little more stable. One thing about this pan zoom, your horizon line just is not anywhere near where it actually is when you're out of pan zoom, so ignore that for the time being. And when you have those things that you're trying to observe in the 2D pan zoom, you can jump back out of it. And so our horizon line did move on us. We'll want to get into our camera, move it back down where it belongs. And then again, we can start to use these tools to help us get the building back into place. And we're starting to get pretty close. There we go. And the last thing to check is the height of the camera. I'm taller than 9 inches, so put that more at like 7 feet, because I'm on a curb. Just the verticals. And test the horizon one more time. And in the interest of time, I'm not going to do this exactly how I had it before, but to show you the camera match that I got from spending, it took me about 10, 15 minutes of just kind of really tweaking those 3-4 things between the transforms and these camera adjustment tools and perspective. I got what I find to be a pretty great match as far as the way the top of the building is rotating around and the way it matches up at the bottom.
You do shaded edges.
Yeah, sorry. Oh, turn off realistic too, so. And then just the last note is really why we would do something like this. Match a building that we have a photo of. This particular project that we're finishing on, they were renovating this building and adding a large canopy to the outside of the building. And one of the philosophies that the senior artist that I work with and I have is that we render as little as possible in terms of a camera match. So we were trying to just render the canopy and match that and its shadow onto the building that already exists so that we can keep the image as photoreal. That's the short of it.
Is there any questions on any of those new features or on, I think one of the pieces that Corey touched on with that Nikon sensor is really important, especially when you get something from somebody that you're receiving an image from an outside vendor. Because if you're working with a photo that was taken with a camera that has a crop sensor, your numbers aren't going to line up at all. And there are certainly known cameras like the Nikon that has that crop. So when I see that in the metadata, one of the first things I do is look up that online and start playing with that field of view, or understanding that my 18 isn't going to be an 18, it's going to be a 24 or something like that, right? So understanding those conversions are always important when you're starting off that base information.
Because the metadata will say Nikon D90, and then lie to us with the 18mm.
And one of the key things too is if you start it and you put in the 18 and you get something really far back, like what Corey was showing, that's one of the, like if you know your position, you kind of know where they took it, and you get a really small building or something like that, one of the first things I would look into is whether or not it was taken with a photo or taken with a camera that had a crop sensor. So something just to keep in mind as a troubleshooting tactic.
And actually, the last thing I'd say is that D90 is a common camera, but I think if you go to the Nikon wiki page, it might just be the DX format, we'll see. But they have a list of cameras that all operate on different crops. I think it's the DX format actually that states it, but the DX format covers a range of a crop from 1.3 to 1.7. So if it's DX format, it can be anywhere within that, and the Nikon tends to move around a little bit. They stick to 1.5 as much as possible, at least that's what I've noticed, but it's no guarantees. Let's see. This guy actually talks about it pretty well. Ken Rockwell discusses it pretty clearly in this blog in particular. I still had to go to the wiki.
So if you're using a tilt shift, I don't know, Canon, one of those, right? And you're kind of like shifting, you're eyeballing things, right? I don't know, I'm getting some feedback things. I don't know if that information of the shifting is actually being captured in any of the metadata. Is there any way to simulate that when you're doing your camera matching?
So I guess your question is how do you recognize if an image is being
so if you have a prime lens, you take and your camera is perfectly aligned, right? You're shooting straight. You kind of, or even if you do this thing, if you're pointing up, you kind of match it. But there's a lot of architectural photography that we get from the photographers that is using tilt shift, and at that point, the field of view is kind of distorted a little bit from the metadata because of the shifting. You have to do, I don't know. I wonder if there's anything on the camera settings that you can do to simulate the shifting out of things, other
In the V-Ray camera, or yeah. So can you pull up a V-Ray camera?
Yeah, I'm in one now. So I think it's us actually.
Or can I drive?
I mean, it's always eyeballing things, and I wonder if there's some mathematical way to do it that gives you like the accuracy that you have been showing. Right?
Yeah. So that's the 24, right?
That's the 17.
So yeah, I'm gonna go
So people who can't see.
over you. So one of the things I've noticed, I use the 17. Let's get to, here we go. So, I guess actually no one's probably gonna be able to see this, but your shift, you have a little scale here, and as you crank this dial, the plate on the back is going to shift. So when I shoot, I normally keep notes of what position or what sort of fractional off of center that I'm shooting my tilt at. I'll say that to answer your question of a mathematical equivalent, like it's not. I can say that V-Ray isn't. When I go 2 ticks, it's not 0.2. For the ones I showed, I shot a vertical correction or like a positive vertical shift of 0.3 and 0.8, and it turned out to be 0.11 or negative 0.11. I think is the value in there. I'm sure if you kept good notes, there could probably be a baseline that you could establish from that. But from what I know of, there isn't any hard and fast rule yet. But as people have discussed, the science of cameras and optics and all those things is fairly scientific. So, and actually what I'm trying to do now, the more and more I shoot, I'm trying to take more and more notes to actually see if there is. So I'm in that discovery phase myself, but I haven't quite gotten the answer. So. Yeah. But in a V-Ray camera too, it would just be vertical offset, right? Which is how you would simulate. What's that? Yeah. Is how you would simulate that shift. And then generally, I try to stay away from doing I use the offsets and try to stay away from any of the fake shifts when I'm using the tilt shift. So, because normally your vertical should be straight if you're using tilt shift. Yeah. I try to stick to just to the vertical up and down, not the horizontal aspect of it.
Yeah. So just to reiterate, those are we have the ability to both to move the entire image up and down, or you can sort of spin the image, which will do perspective correction as well. But I think that we call them tilt shift lenses. The shifting is where you want to sort of reside, because the actual tilting and it's distorting the actual thing, and people who are here can take a look at the lenses. That's harder to compensate for, and it's harder sort of to understand what's going on, because it's distorting the actual image to make the perspective correction, whereas shifting the image is literally as if you could just sort of move the image up the image plane without changing the perspective. And so that's really what is much safer. I'm sure that you guys have.
When you start doing the horizontal, it has the same increments as the vertical, but your image really starts to get weird. That's the best way I can describe it. It's kind of like moving. It's kind of like horizontally moving a fisheye lens is how I describe it. So what's going to happen is the edges of your image are going to start getting distorted. But it can be useful for particular things, and that's, as Nils asked, I try to just stick with up and down, because I try to do my best to get the right position, so all I'm doing is up and down, because it's also going to make it easier to match, because you're only dealing with one variable. All right.
Okay, so I think we're going to take a quick, call it a 10-minute break. We're going to do a switch over, and if anybody here wants to take a quick rest break, then we can do that. So it is now quarter after, so be here at 25 after.